Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video provides worked out solutions for Sample A of the CUNY Elementary Algebra Final Exam. Sample A can be found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now, please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may, therefore, differ somewhat from those used by your instructor. This is normal and to be expected. So if you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in only one way in order to avoid confusion. However, occasionally I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck, and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Question number 10 asks you to factor the given polynomial. Now, when you see four terms, remember a term is something that's being added or subtracted. The way to factor it is by using the method called grouping. There's no guarantee that it can be factored, but if it can, we want to go with grouping. So to begin with, we group the first two terms. And what you want to find is, you want to find the GCF, the greatest common factor, of these first two terms. So what we do is we look for the largest number that divides into 21 and 14, the coefficients. So the largest number that does that is 7. And then for each letter that's common to both terms, in this case that will just be a, we write it with its lowest exponent found. Well, since the exponent of both a's is 1, we'll write a. So we have 7a. Now we multiply. 7a times what will give me the 21ab. So 7 times 3 will give me 21. And now we have the a, so I need b. So if you multiply these two together, you get the 21ab. Now we subtract. Now 7a times what will give me the 14ax. So it'll be 2x. And if you multiply these together, if you distribute, you should get the first two terms. Now what you want to do is to repeat the binomial factor 3b minus 2x over here. And what we want to know is what times 3b will give me 15by. So we see that will be plus 5y. Now you might say that gives me 15yb, but keep in mind that the order in which I multiply does not matter, so you can equally well say 15by. And let's check the last term. 5y times negative 2x is negative 10yx, which is the same as negative 10xy. Well, now we see you have a common factor. It's a binomial factor, but it is a common factor. So we take it to the front, and what we have left is 7a plus 5y. Now the problem asked us for a factor, not both factors. So when we look at our factors, we see the one that is present in the choices is choice A. Now, in case you did not understand how we went from this line over here to the final answer, take a look at the right here. I've substituted the magenta 3b minus 2x here and here with z. Now, if I ask you to factor this problem over here with the z's, you would say, oh, okay, z is common, so I'll bring it to the front, and I'll be left with 7a plus 5y. And when I distribute, I see I get what I started with. Okay, well, we said that we substituted 3b minus 2x with z. So let's remove the z and put it back as what it is, 3b minus 2x. And if we do that, we see we get the final answer that we got on the other page. So I hope that clears things up. In problem number 11, you're asked to translate the English statement 15 is 12 less than 2 times a number into mathematical notation. Well, the beginning is simple enough. We say that since we say 15 is something, we'll say 15 equals. Now, what's the operation going on here, the major operation? Well, it says 12 less than something, 12 less than 2 times a number. So the major operation here is going to be subtraction, something minus something. Now, whereas in math, there's only one way to indicate subtraction, namely the minus sign, in English, there are several different ways. One way, as we see, is less than. Another way is less. You could have decreased by. We could say minus, reduced by. I think you get the idea that there are many different ways. The reason we care is because the particular words that are used will indicate which number is going to be subtracted first and which number comes after the minus sign. One of the ways I like to figure out which comes first is by imagining what would I put in a calculator if I were allowed to use it. Like, for instance, let's say we had 1 less than 4. What would go in the calculator first? I think most people will agree you would put 4 and then subtract 1 to see that 1 less than 4 is 3. So similarly here, since we have less than, the number that appears first in the subtraction will go second, and the second number that appears second, 2 times a number, will come first. And I've chosen n here because the problem stated that let n represent a number. So this 15 equals 2n minus 12 is the final answer. One more note, when you determine your mathematical statement, it's a good idea to compare it to the English and see if it's a reasonable representation in math of the actual English you were given. In problem number 12, you're asked to solve for n. So all the algebraic manipulations we'll be going through will be to get this final line, n equals some number. So let's begin. So we want to solve for n, and one of the n's is inside the parentheses, so we'll have to begin by distributing. So 5 times 8 is 40. 5 times negative n is minus 5n equals 3n minus 16. Now, we want to get the n's, like we said, on one side of the equation. We want n equals number. We don't want n equal n. So let's begin by adding 5n to both sides. So after we do that, we'll have 40 equals 8n minus 16. Now we're closer to our solution because we have n on one side of the equation, but we don't want n with numbers equal a number. We just want n equal to a number. So we'll add 16 to both sides, because in doing so, the negative 16 will go away. And adding the two equations together, we'll get 56 equals 8n. And to remove the 8, since we just want 1n, since 8 is multiplying the n, the way to undo multiplication is to divide. So we'll divide both sides by 8. On the right side, the 8's will cross out, and the final answer will be 7 equals n, which is choice D. In problem number 13, you're given a system of two linear equations. By a linear equation, we mean that the exponents of all the variables are 1. Remember, the exponent is not written, it's understood to be 1. Now, solving a system of two linear equations in two variables, graphically, since each equation is the general form of a line, what it means is finding the intersection. Now, it may be that two lines don't intersect, they're parallel, but they'll give you a problem in which the two lines do intersect. Now, they're only asking you to find the y-coordinate in this problem. So if you initially find the y-coordinate, you're done. If you find the x-coordinate, then all you have to do is substitute that x into either equation to find the y. Now, there are two algebraic methods to solve a system of two linear equations and two unknowns. Either may be used. However, for a given system, one is usually going to be easier. These two methods are substitution and elimination. Substitution is usually used when one of the variables has a coefficient of 1 or negative 1. Remember, a coefficient is the number that is multiplying a variable, telling us how many of that variable we have. Elimination, on the other hand, is usually used when none of the variables has a coefficient of 1 or negative 1. Now, in our particular example, as you see over here, since the x has a coefficient of 1, now it's not written, but when it's not written, it's assumed to be 1. And therefore, we're going to use the method of substitution. Now, it's a good idea to label the equations with a number. So I'm going to call the first equation equation number 1, and the second equation equation number 2. Now, using the substitution method, I'll just indicate that here, we're using the substitution method. The first thing you want to do is solve for the variable you have identified to have a coefficient of 1 or negative 1. Since there's no coefficient written for this x, it's assumed to be 1. Now, what we do at this point is solve for the variable whose coefficient you've identified to be 1. If there's more than one variable whose coefficient is 1 or negative 1, you can solve for any of those variables. So I'm just going to repeat equation number 1 here, and I'm going to solve for x, which is very easy because the coefficient of x is 1. So I subtract 3y from both sides to isolate the x, and the result is x equals 2 minus 3y. Now, I substitute. I'll go into equation number 2, and I begin equation number 2 with negative 3. Now it says negative 3x, but I just solve for x. So what I'll do here is I will substitute the previous value I've solved for x, 2 minus 3y. So I'll place 2 minus 3y here, minus 8y equals 4. I'll solve for y, and I will have answered the problem. So first we have to distribute. So negative 6 plus 9y minus 8y equals 4. We combine like terms. 9y take away 8y is simply 1y or y. And if we add 6 to both sides, we're going to get the final answer. Y equals 10, which is choice B. Let's solve the system we just solved with substitution. Let's try solving it using the elimination method. Now, another name for the elimination method, aka also known as the addition method. What we're going to be doing once we've done the necessary algebraic manipulations is to add the two equations together. Now, we're allowed to add the two equations together because even though we'll be adding the left side of equation number 2 to the left side of equation number 1, and the right side of equation number 2 to the right side of equation number 1, since they're equal to each other, we're going to be adding the same value to both sides of equation number 1. Now, the reason this method is called the elimination method is because when we add, we want one of the variables to drop out. As these equations stand right now, if you add them together, neither variable will drop out. But if we examine equation number 1, we see that if we multiply both sides by 3, so let's do that. Remember to multiply the entire side. So the new equation number 1 is 3x plus 9y equals 6. Now let's bring down equation number 2. I'm not going to make any changes, just going to write it. And you see we have negative 3x minus 8y equals 4. Now it's time to add these two equations together. In doing so, you see what happens. The 3x take away 3x will drop out. 9y minus 8y is y. 6 plus 4 is 10. Now, had they asked you to solve for x, you would now substitute the y value of 10 into either equation to solve for x. Problem number 14 contains a literal equation. Literal comes from the word letter. A literal equation contains more than one variable name. In this case, we see we not only have the letter x for which we're trying to solve, but we also have variable names y and z. Now, the method used to solve this equation for x is the same as if the only variable name were x. So let's see how that works. Let's temporarily change the equation we started with, and let's say the equation were this. Instead of z, we had 8 equals 5x plus our y of 3. Now, how would you solve this equation? Sure, you know how to solve this one. We'll just subtract 3 from both sides. So we'll get 5 equals 5x. And to solve for just x, we'll divide both sides by 5. The 5's will cancel out on both sides, and you'll be left with 1 equal to x, or x equals 1. So let's just do the same thing for our example. We see that the first thing we did was subtract the 3, but that's just the y. So let's subtract y from both sides. On the left side, we get z minus y. Now notice that z minus y, those two variable names cannot be combined because they're unlike terms. And on the right side, we get 5x. The next thing we did in our example was to divide both sides by 5. So let's do that. We'll divide both sides by 5 to isolate the x. And now the x is isolated. The 5's cancel, you'll have x. On the left side, you're going to get z minus y divided by 5. And if you look at the answers have x listed first, but that's fine. So where do we have x equal z minus y over 5? Choice B. So that will be the answer. Problem number 15 has an equation which we called a quadratic equation. A quadratic equation is one in which the highest exponent is 2. Now the general form of a quadratic equation is ax squared, some number times x squared plus some number times x plus just some number c equals 0. Now when you have an x squared term and an x term, or in our case a b squared term and a b term, there are different ways to solve the equation. We're going to use the method called factoring. So the first thing you have to do is set the equation equal to 0. Well, they've already done that for you. The next step is to factor. Remember, the first step in any factoring problem is to find the greatest common factor, the GCF. We see here that 4 is the greatest number that divides 4 and 8. b is common to both terms. We use its lowest exponent of 1, so the GCF is 4b. So what do we need to multiply the 4b by to get 4b squared? B. And then what do we need to multiply 4b by to get 8b? 2. So if we check it, we see that we have 4b squared plus 8b equals 0. Let me just write over here that this is the GCF. Now there's a principle in mathematics that if you have two numbers that are multiplied together to give you 0, can you say anything about either one of these numbers? Well, it must be that at least one of them is 0, because otherwise how would you get 0 when you multiply the two numbers together? Now in our example, what we're doing is we're multiplying 4b times the other factor, b plus 2. Since it's equal to 0, we can make the same conclusion, that either 4b equals 0 or b plus 2 equals 0. Well, if 4b equals 0, if we divide both sides by 4, we'll get b equals 0. If b plus 2 equals 0, we'll subtract 2 from both sides, and we'll get b equals negative 2. So our two solutions are b equals 0 or b equals negative 2. And you can check this. If you plug in b with 0, you'll see b squared is 0. 0 times 4 is 0. 0 plus 8 times 0 is 0. If we plug in negative 2, you'll see we get negative 2 squared, which is 4. 4 times 4 is 16, but 8 times negative 2 is negative 16, so they combine to give 0. So the solution of b equals 0 or b equals negative 2, the answer is going to be choice D. And this is what usually happens. When you have a quadratic equation, you usually have two solutions, which is the case here.